This is it. I'll pass it around, and if the camera wants to take a look.
Can you just keep it steady for like 30 seconds and I can take care of it from here?
That's so bad.
We're living in the future. That's all there is to say.
And if you want to turn it slowly.
I grew up in this house. The basement's not there, that was my room. And I would sneak out at night to hang out with girls. And I'd come in and my parents would be like, "Where were you?" And I would say, "Out."
You got a secret passage?
And that's my story. Yeah, the secret passage is right here. And it goes into the basement. That's where I live. That's my story. And I forgot a door. But you guys don't need to know that. There, I'll pass it around for all this. But it's fun. RepRap is totally bad arse.
What's the infill percentage?
It's like, I think it was 35%. Just the lines, you know, back and forth and zigzag to give it some structural integrity.
Do you change the angle every layer, or do you keep it on?
I keep the angle all the same, so it builds up like I don't know. I think it's good for structural integrity.
It'll switch, right?
Yeah, it goes back and forth, like one, all the way like across. And it's the first couple layers are full.
What was your layer height?
0.2 millimeter.
Nice.
Layer height with a 0.35 millimeter nozzle. Is that right? Yeah.
You talked about the hot ends dying.
Yeah.
What's the usual cause of hot end death?
I'm not. Somebody else probably have a better answer. Ours clogged, and then we had a ceramic like covering, and that was kind of breaking apart.
Okay.
And in the end, it was just we didn't really know what to do with it, and it was kind of like just so demolished that we decided to buy a new one from Mix Shop there in Toronto. But we have this block. What's it called? Block. Aluminum meter block, which seems to be pretty good and consistent. It doesn't break down.
How do you handle overhang? There's substantial overhang with this.
That being said, I designed the house all the way like to be printed. I guess like I kind of just guessed with the overhang, and it worked. But it's like more. It's like less than I don't know. It's better than that. 45 degrees is like. That's not like a lot sharper of an angle than 45 degrees. So,
That's awesome. Well, thank you very much, Andre, for reminding us that we're living in the future and for also helping us. So I'm going to talk again briefly, and I'm going to talk about ImplicitCAD. So ImplicitCAD has been the last 3 months of my life, and I am proud to be showing it to people. It's a very large project. So it began as a computational geometry engine for Haskell. So you go and you ask for unions of things or differences of things or so on, and it goes and it does those and turn in Haskell, not Seagal, thank goodness. So that's what it began as. Now, actually, I should step back. And who here is familiar with programmatic CAD as an idea? Okay, so we need to explain what programmatic CAD is. The basic idea is that you're so oftentimes when CAD is computer augmented design, and often when one wants to design something, one goes and you use a nice pretty GUI interface, and you go and you move things around, and you go and you build your object that way. And the idea behind programmatic CAD is that we can go and apply a lot of the ideas from programming to designing these objects. So you go and you have some text file that is your source code, and it compiles into your 3D object instead of compiling into a program. And you can use if statements and for loops and whatever else, functions, and by doing this, we can go and make things parametric. We can go and, if you have a gear, you can have each tooth be a loop and a step in your loop, and go and make it so you can go and just change that by changing a number, which is really cool. And moreover, that one can go and put it in, or maybe not moreover, but one can go and put it in revision control, and can go and put it up on GitHub. And in fact, the Prusa, and we have a number of Prusas here, was done that way. So programmatic CAD is really cool, and the existing one is OpenSCAD. But what we're doing here is we're going and we're trying to improve on OpenSCAD. So one feature that we've so after that, people have an irrational fear of Pascal, if they've heard of it. Who here has heard of Pascal? Who here is terrified of Pascal? Yes, okay, so 50% of the people who have heard of Pascal are terrified of Pascal. It's not the greatest turnout for a programming language. So we went and we implemented an OpenSCAD parser. And you can see it over here, or an example of OpenSCAD here, and or of our ext OpenSCAD, because we've extended it, and a rendered object, and I'll step you through it. So what we do is we declare the resolution to be 5, and then we go and we are going to linear extrude to a height of 40, a centered object, with a twist described as a function. So you can go, you don't have to go and twist a constant amount when you're extruding. You can give it to the program as a function, and it'll go and twist however you've asked it to. And then what are we extruding? Well, where did my mouse go there? We are going to go and extrude a rounded union of 5 circles. All of them have a radius of 10, and 4 of them are translated to different corners. So if we go and we tilt the object on its side, you can see it. And in fact, let's go and change the resolution so that we can get a nicer result here. That'll take a second. So this is a web interface. We can thank Rob for writing awesome web interfaces. It will soon be publicly accessible. It's not available yet, but soon will be. So here's our higher resolution object, and you can see now that it's a bit smoother, and you can see the nice rounded interface. So the idea behind a rounded union is that we go and we round the interface between the two objects. Perhaps it would be more instructive to go and do a square. So first let's go and just make it so that we're going to extrude a constant amount, like 10. And then we are going to go and union a square of width 10, or actually let's make that 30, with a translated. Now watch me make a syntax error because I'm typing in front of people, and that's just what happens when you're typing in front of people. Wait. Square 10, right? Square 30. There we go. So now you can see that instead of there being, if we did a strict union, we would have just a sharp interface. But the rounding goes and rounds the interface between them. And that works in 3D as well. So this gives you, oftentimes your objects, if you build them in OpenSCAD, they look somewhat artificial because they aren't roundly going and combining together. They just look like a bunch of things that have been stuck together. And or you can go and spend a lot of work going and unioning little cylinders and spheres and so on to go and get things to look nice. But with this, you don't have to do it. Just don't tell it, oh, I want this rounded between these, and so on and so forth, and you're done. And so there's a number of other cool features that I won't get into. You're welcome to go and look at the GitHub page, or go and bug me afterwards. What am I?
We also have that running on the local network. So.
Yes. In fact, if you go to, what is it? 192.168.111.231 port 3000, you can try ImplicitCAD. Today, made by real hack clappers.
You got it?
And we have some other examples of things made in ImplicitCAD, so extrusions, twisted extrusions, blah, 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 blah. 2D examples. Okay, I need to get more of some examples on here. If I go to the blog post for the 0.01 release, you can see some more examples. So here's a rounded extrusion of a rounded union of 2 squares. We did something just like that right now. Okay, actually don't have too much cool here. Too many things that are that cool here. But you can, so there's examples floating around. If you want to try it again, it's not ImplicitCAD.org, that doesn't work right now. 192.168.111.231, port 3000. So if you have a laptop out, you can go and try that.
We'll load it up on that computer afterwards.
Awesome, that's really good. In the next, here, let me go and pick a round units so that we can go and emphasize how awesome the round units are. People who want to bug me, by the way, this has been like a project of going and clobbering computer science problems with mathematical hammers, and it's been lots of fun. So if people are interested in math, you can also bug me about that. There's all sorts of cool stuff involved, including topology. I applied algebraic topology. That's quite something. So in any case, though, I'll stop here. Thank you very much for all the people who spoke. That's greatly, greatly appreciated. And next time, you too can be a speaker at the Toronto RepRap User Group. And in fact, I will be very grateful if you were. So thank you to all our speakers, and have a great evening. This is far from the end of the Toronto RepRap User Group meetup right now. We can socialize and show off things, and you can talk to people that gave cool presentations that you want to hear more about. Or you can look at the awesome 3D printers, like the giant Mendel that's really impressively quiet and printing right now. Yeah, it totally is. You can't hear it, but it's amazing. In any case, thank you very much. Yep.
Nice.
So I have to ask, how did you get it so quiet?
Reduce the current going to the motors. And then the next question you ask is, how do I get it to not skip steps
Yeah.
while
Yes.
doing that? Lower the acceleration and lube everything.
That's badass. That was awesome.
Asking about lube?
I just use.
So Chris, should I shut?
I did.
Yeah.
Oh, I
Thank you very much for filming.